Good morning. Thank you so much for your time today. My name is Tom Ye, and it's my pleasure to speak at the West Coast NLP Summit. I'm here to talk about an intriguing problem about chatbots. What is the problem? There are a lot of bad chatbots out there. I'm not talking about chatbots made by bad guys like hackers, scammers, or foreign spies. I'm talking about chatbots made by good people with good intentions but with unintended consequences, sometimes bad consequences. Why do good people make bad chatbots? Let me tell you a story to illustrate this problem. Same. Same is a really good person, and she runs a flower shop. She has a website for customers to place orders online. And because of COVID, online ordering has gone up recently. And to meet this demand, Sam decided that she wanted to add a chatbot to the website. Fortunately for Sam, now there are quite a few platforms for designing chatbots that do not require any prior programming experiences. Sam decided to give one of those platforms a try. And without much effort, she was able to design a conversation flow of a chatbot for taking online orders for flowers. And the chatbot is a big hit. Customers laughing at. But not every customer was happy. Sometimes the chatbot behaved badly. For instance, Kyle. His friend recently passed away because of COVID, and Kyle wanted to send flowers to his friend's family to offer his condolence. Initially, Kyle's conversation with the chatbot went quite well until the chatbot asked, "So, what is the occasion the flowers are for?" Kyle said, "My friend passed away." Chatbot said, "Great, got it, thank you." Kyle was taken aback by the chatbot's complete lack of empathy. Kyle feels sad. And in this scenario, the problem here is lack of empathy. But there can be other problems, such as biases, privacy intrusion, and hate speeches, and so on. Who should be responsible for these problems when these problems occur? Well, we may blame Sam. After all, Sam was the one who designed the chatbot. Perhaps Sam shouldn't design a chatbot to ask the question, what is the occasion? Perhaps Sam should have made sure that chatbot can prepare a more empathetic response to bereaved customer like Kyle. Perhaps Sam should have taken her time to study the best practices in designing a chatbot before she designed it. Or maybe that's not be too harsh on Sam. But if it's not Sam's fault, who else? It's time to talk about Jordan. Who is Jordan? Jordan has a PhD in computer science with specialty in conversational agents. And during his PhD study, he built a lot of chatbots. And he knew how hard it is to build a chatbot. After graduation, he and his friend had this idea. Wouldn't it be nice if anyone can build a chatbot? Sam and his friend developed an online tool just for doing that. And this tool became really popular and is being used by tens of thousands of people around the world. A lot of people without any programming experience were able to use Jordan's design tool to build a chatbot, some for fun and some for practical reasons. Like Sam, who made a chatbot for an online flower store. So, when Kyle had a bad experience with a chatbot, to what degree should Jordan bear some responsibility? Many people take hold the view that it's nothing. Jordan is just an engineer. Jordan is just a tool maker. Sam is the one who used the tool incorrectly. But recently, this view is being challenged in our society. When tools are misused, like perpetrating filter bubbles, affecting people's emotion, propagating hate speeches, or even influencing elections, tool makers like Jordan can no longer claim innocence. So going back to the problem I was stating earlier, why do people make bad chatbots? I don't want to argue that it is because good people like Sam receive extremely powerful tools from people like Jordan. So that Sam can quickly and easily make chatbot. And it all sounds good. Um, but Sam received no help whatsoever to test and make sure that power is not misused or abused. So that is a problem. And who do you think could be best positioned to address this problem? Well, I think I want to make a case that there would be people like Jordan who actually make the tool, not Sam, and definitely not Sam's customers like Kyle. What it means that will require Sam really has to step up, and take some responsibilities. And what would the best thing people like Jordan can do to give to the Sam? I would like to argue that there will be a self-test kit for chatbot, so that good people like Sam can use this self-test kit to test her chatbot to make sure the chatbot she's making is a good one. I'm going to talk more about this self-test kit, and I'll focus on three keywords. The first keyword is possible. I'm going to review the literature that give us the technical ingredients to make it possible to create this test kit. And the second keyword is easy. If we simply put all these technical ingredients in a box and hand it over to Sam, it probably wouldn't be too helpful for Sam because these ingredients were originally developed for experts like Jordan. I will talk about how we can make this toolkit easy to use, a lot easier to use, using XCI research methodologies. The third keyword is better. I will describe an experiment that we ran to demonstrate that a self-test kit, like the one that we envision, does help people like Sam create better chatbots. Better chatbots. And what is my goal of sharing my vision for this test kit with you? I hope some of you will decide to take action to help turn this vision into reality, to help many more good people design good chatbots, to benefit many more users out there. And what action am I talking about? At the end of the talk, I would like to offer some concrete examples, such as participating in a 1 minute survey to share what you think are important to include in this test kit. Possible. I'm going to discuss two technical ingredients in the literature that made it possible to construct a self-test kit. First is the literature on user simulation. When we talk about here the word user simulation, a common and dramatic imagery would be from a car crash test. In the 70s and 80s, believe it or not, crash tests sometimes used live human volunteers. And when crash test dummies were later introduced to simulate the impacts on human users, we all agree it's a much better and safer idea. And that principle applies to testing chatbot as well. Having a user simulator is much better than relying on real customers like Kyle. And there are two typical approaches to user simulation. One approach is a rule-based approach, where a domain expert typically will handcraft a set of rules to model a user's behaviors. And this model typically includes goals, what the users want to achieve, such as I want to order flowers, actions, what the user will say at each conversation turn to get closer to the goal, such as answering yes or no, or making a selection, or sometimes even quitting. And also, knowledge is what users may or may not know at a particular turn of conversation. And as an ongoing conversation can continuously update this knowledge so that the user does not ask the same question twice. Another approach is a data driven approach. Instead of handcrafting a set of rules, this kind of approach would like to take a set of transcripts that contain realistic conversations between users and a chatbot and try to derive those rules automatically. Both approaches, the data driven approach and rule based approach, have been shown to be quite effective in simulating how a user may interact with a chatbot. The second technical ingredients I'd like to talk about are the evaluation metrics for chatbots. And there's a growing body of literature on this. Typically, they fall into two categories. The first categories of metrics are about the objective system performance, such as the task completion rate, how likely can users achieve their goals by talking to a chatbot, and length of conversation, how many conversation turns does a user typically need to, to complete a task. Another category are subject human experience, such as trust, empathy, satisfaction, and so on. A popular method is to train a model to predict this subjective rating using a data set of labeled conversation examples. And suppose we have trained a model, say on predicting empathy. What can we do with it? Let's revisit the situation Kyle encountered in my earlier story. When Kyle said, "My friend died," the model will predict a high level of empathy. And when the chatbot responded, "Got it, thank you, great," the model would predict a low level of empathy. And this mismatch will immediately suggest there's a problem. So we can definitely put a user simulator and evaluation metric in a test kit, but will Sam be able to use it? Probably not. Easy. How can we make a self-test kit less easy for a non-technical chatbot designer like Stan to use? This question is actually the dissertation topic of my PhD student, Xu Han. She has worked on this problem for more than 3 years. And this topic is in the intersection of human-computer interaction and natural language processing. What was the original motivation for Xu to study this topic? Back in 2018, I was teaching an HCI class, and this is a large class. There are almost 200 students. She was an TA for my class, and she helped me with team projects. And for team projects, students are expected to design and develop an Alexa skill. We gave each team an Echo Dot, and for a final presentation, we used one of the largest labs on campus. We asked each team to bring their Echo Dot and set it up, load it with their Alexa skill. And we walk around and test each Alexa skill by actually talking to it. And there were 40 projects we needed to test and score. And some projects were amazing, and some projects were just, well, bad. And we ended up doing tons of talking and listening. And we found, well, it's just very interesting to look at all these projects. And the evaluation and testing process quite tedious and time consuming. How can we make testing better and easier? Would it be nice to automate this process just in case we have to teach this class again? The idea of building a simulator came up. And that simulator, we can have that simulator do all the talking, listening, and scoring for us. And we don't have to do anything. Sue took on the challenge to build a simulator and came back with a functional prototype after a while. And so we're eager to test how well the simulator works. First, as proof of concept, we apply this simulator to test the Alexa skills created by students in my class. Next, to scale up, we apply our simulator to test a sample of 100 real-world Alexa skills across 10 categories. Keep in mind that all of those skills were developed by third-party developers. We're able to obtain interesting statistics on problems these simulators have surfaced, like what percentage of Alexa skills did not provide useful help messages, what percentage of Alexa skills did not include greeting messages, what percentage of Alexa skills did not handle errors at all, etc. When we published our findings at the second workshop on user-aware conversational agents, we got pretty good feedback. But to get to the self-test kit I've been talking about, there are quite a few hurdles, few things still missing. Yes, we know our simulator at the time does make testing a bit easier, but for people like Sam, we don't really know whether it would be good and easy enough. Yes, we know our tool can uncover design problems, but we don't really know whether Sam has all she needs to know how to fix those design problems. We realized we needed to talk to Sam more, which means a user study. We recruited people like Sam, we ran interviews, and we tried to understand how often do people test chatbots, what difficulty do they encounter, and what kind of assistant do they think they prefer. And what did we find? We found three things regarding people's preferences. First are scores. People like to see numbers, scores. Quote, I hope to receive the score my chatbot will get. Close quote. And second things people prefer to see are the problem spot, the location of problems. Quote, it would be great if someone can tell me where I did wrong. End quote. The third thing people like to see were the recommendations. Quote, I'm afraid even I was told this part should be improved, I still don't know how. End quote. And another quote, design suggestions would be of great help. End quote. And these user preferences that's they have uncovered from the interview could be turned into design requirements for the self-test kit. For scores, for instance, we can report the empty seems like empathy score is 3 out of 5 and the privacy score is 4 out of 5. These numbers could be really helpful. And for problem spot, for instance, we could point out things like the fifth utterance as lacking empathy and the 12th utterance as intruding privacy. The third requirement about recommendation, there will be things like adding I'm sorry to hear that to certain utterances. Suppose we put together a test kit based on all these requirements. Will it really make a difference? If so, how can we demonstrate that? Better. We are claiming that a self-test kit can help designers create better chatbots. And to substantiate this claim, we ran an experiment and hope to demonstrate the benefits of the self-test kit. And what do we need for the experiment? We had a prototype, we chose a platform, and we designed scenarios and we recruited participants. And for the prototype, we built a working prototype of the self-test kit by implementing a user simulator. We also implemented 11 evaluation metrics that could be automatically computed. And we designed and developed a GUI based on requirements from our user study. And this GUI will show scores from the metrics, and it will highlight problems, and it will offer recommendations. About the platform, ideally, we would like the platform that we test our toolkits on, test kit on, will have the following attributes. The platform should have lots of users already designing chatbots on the platform. And so we know that our test kit will have a real world applicability. And the platform should be easy to use. So people like Sam without programming skill could use it. And powerful, the platform should be powerful. offers lots of options and functionalities to customize the chatbot. We chose Juji because it has these attributes, and we are pretty lucky to be able to collaborate with Juji's team to run this experiment. And next, we needed a scenario. We needed a reason for people to make a chatbot. We wanted a reason to be interesting and relevant. And we settled on COVID-19 interview chatbot for people to design a chatbot to monitor symptoms, asking questions like, how are you doing today? Do you have a fever? And so on. And for participants, we recruited participants to represent SAME, the designers. We divided the participants into two groups, A and B. For both groups, we gave them a baseline chatbot. It already did some basic COVID interviews, but not great. We asked them to improve it. For designers in group A, we gave them our self-test kit. And for designers in group B, although they were also asked to improve the chatbot, they were not given our self-test kit. And then this way we could compare the effects of having our self-test kit. And we also recruited participants to represent users like Kyle. And this participant will interact with the chatbot designed by people in A, and some will interact with the chatbot designed by designers in group B. Then we asked this participant to rate their experiences, and we also got transcript of their interaction that we can analyze. What do we find from all this? Overall, we found chatbots from group A were better designed. Of the 11 metrics we tested, we found significant improvement in 8 of the metrics. Users were more satisfied, responses were more informative, more empathetic, and there were fewer repetitions, and so on. And these numbers seem to suggest that the self-test kit was making an impact. It was indeed helpful. What do people really think about this self-test kit prototype? I would like to offer some quotes from the interviews. Quote, these conversation examples are useful. They inspire me when making chatbot customizations. End quote. This seems to suggest that designers found design suggestions helpful. Another quote, I read the bad example and realized that some people might not like this kind of questions directly asking for their personal information, so I changed it. End quote. This quote suggests that designer did learn something new from the suggestions and act on it to fix problems related to privacy. Taken together, what is the contribution of this experiment? It offers one of the first empirical evidence to substantiate the claim that a self-test kit like the one we envision can help designers make their chatbots better. In summary, I started off by highlighting the problem that good people are making bad chatbots. Now I made the case that a solution could be to give these good people a self-test kit and build my case around 3 keywords. It's possible given what's in the literature, and this test kit can be made easy to use, and the outcomes will be better based on empirical evidence. And you are convinced that there's a value for people like Jordan who represent NLP or HCI researchers like you and me to work on this self-test kit for designer and users like Sam. I hope some of you will take actions. First, the easiest action will be to simply take a moment to reflect on the following questions. What tools are you already using to test your system? Second, if you have time, you can take a 1-minute survey to share your thoughts with us. And third, if your team does have a good tool for testing, discuss with your team how you can share them. With enough actions, I have hope that good people with good intentions will be able to make good chatbots. Thank you. I would like to take questions and continue this discussion with you.
So, hello. Thank you very much for that talk, Tom. So we're now ready to take a question or two live so that we don't run too long. So, Tom, there's a couple of questions for you, or at least one more question. I see you dropped in the link for the survey. If you want to join us live, there was a question, let's see, up here. Albert, thank you for a great talk, and says that building a simulator to test bots can save a lot of time and effort. Do you have any thoughts on the most salient dimensions we should probe for a task-oriented bot?
So we started off our early work in the story about Alexa, and it's a very text-oriented. And then in more recent work, that we expanded to chatbot. And so going back to our test orientation chatbot experience, we found that there's some easy one like test completion. That's kind of obvious. Of course, you have to test for that. And then most of the vendors of text-oriented chatbot or conversational agents are probably doing that. So that's my response to that question about what would be the most salient dimension. Or I probably would try to advocate some of the not so obvious the properties like user satisfaction. Are they making some assumption about users? Are they some, especially when chatbot become popular, that you can measure across user population. You can measure things like biases, other chatbots more likely to succeed for certain population versus the other user population. So that's probably what I would kind of turn that question into something that might not be as obvious. You don't usually test, perhaps across the board, common universal test platform and benchmark can help us all cover our ground well.
Thank you. There was another question, probably the last we'll have time for, from Aditya. Is saying they may have missed this, but what does the test kit actually look like? Is it a collection of sample input and output as generated by the chatbot model, or is it something else?
The question is, we're exploring various places we could put the test kit in front of the designer. And one is that after they have already designed, and then maybe they could bring this kit, and itself is actually could be a chatbot, and they could talk to your own chatbot. But we are thinking that probably the most effective place to put that self-test kit is actually part of the design environment as they are designing. And that it's almost like when we started to code many years ago, there wasn't such thing as integrated continuous integration testing. There wasn't such thing as unit testing. And over time, they got integrated into the IDE and become very effective for programming to catch bugs at the very early stage. So that's what I believe is that for testing AI application like conversational agent, that could be where we are going. We're starting to have better and more robust testing tools, and we would like to see them be integrated into the design environment so they could address some issues earlier rather than later.
Great. Thank you again for a wonderful talk and for highlighting these really important questions for our field as the technology becomes more and more part of everyone's lives. So we're going to move on to our next speaker. That's Dr. Samir Singh. And he will be rounding out our session here. He is a professor of, an assistant professor of computer science at the University of California, Irvine, and was a postdoctoral researcher at the University of Washington after receiving his PhD from the University of Massachusetts Amherst. But he's also done some work at a variety of important industry labs like Microsoft Research, Google Research, and Yahoo Labs. He was selected as a DARPA Riser and has received many other grant prizes in challenges and also the Hellman Fellowship. He has published extensively, receiving Best Paper Awards at conferences, including this year's AKBC and also ACL 2020. Dr. Singh's work focuses primarily on robustness and interpretability of machine learning algorithms, along with models that reason with text and structure for natural language processing. And today we'll be hearing Dr. Singh's talk, which is Evaluating and Testing Natural Language Processing Models. The talk is going to be a played recording, but he'll be here for live Q&A and has generously offered to be in the chat during the talk to answer any questions that you have. Thank you very much.
Hi, I'm Samir from University of California, Irvine, and today I'm going to be talking